Okay, so this is my demonstration of Oregon Trail. So here we have the main page, so if you click the home, you go here. Currently we're not logged in, so if you click user page or leaderboard, we can see the leaderboard. But we have to log in in order to see the user page. So we can also create a new profile. So basically, we'll do Tom. And then we'll do a password. Our name is Tom, and we are 24. Or we'll do 25. So we add this. Okay, so here is our new game collection. So we can create a new player. So we'll call this player after ourselves. I don't know. I always come up with bad names. And then, well, you can set the gender, and we hit create. So then we move over to the create new game. We can create our character. If we want, we can create another character, or we can just go back and keep creating our game. So here we have all new characters. So we want our main character to be our new character. And then we can just select pre-existing characters. It's set up right now too, so that these are basically with fresh stats, so we don't have to worry about any of that. So we hit create our game. So now we have a game that's active here. And it says it's true, so then if I lost all my players, then this would be set to false. And then this tells us our miles traveled, the current day, the current season, our player one, and then our player one's gender. So we can select to play it, or we can select to delete, which I can show in a moment. So here we have our wagon health, our food, these are our miles, and this is our money. For demonstration purposes, the day is going to tick up every 2 miles. You can set this to be anything you want, from 10 to 15. 15 is what it was originally and what I would think it would be in a full release, but for demonstration purposes, it's easier to see. Here we can stop. So this prevents the miles from ticking, this prevents the day from moving, so our characters pause. In the future, I'd like to link this to things like resting, or this could just be the pause button here. So each of these characters is eating every single time they do a mile. We can sort of see this in the developer panel here, because a lot of this is being called. So basically this here is the stomach. Oh, so we have our first injury. So one of the characters broke their leg, so you select OK. So some of this stuff happens under the hood, but when you break your leg, there's a bunch of different stats, which I can show when I briefly overview the code. So this method here actually determines whether or not the character dies. So when you get hurt, you have a death chance. And here is the health, or the hunger. So your stomach has a certain amount of food in it, and then when the stomach goes below 50, everyone eats from the stock, and then your stomach goes back up to 100. When this goes all the way down to 0, then health comes out of the wagon. Oh, so minion 1 just died, unfortunately. And I think that was with closing the window. Sometimes it appears twice. But as we can see now, the character is gone. So unfortunately they have died. If we save at this point, and we refresh, the character is still dead. And yeah, so Tom now has dysentery, unfortunately. Again, a lot of these injury chances and everything are bumped up so that it will actually show during a demonstration, but wouldn't necessarily be this frequent in a full release. And so then if we just keep going, okay, well now Chad has cholera, and Tom has died, unfortunately. So if we save our miles here, and refresh again, we can look at our leaderboard, and we can see that we made it 26 miles and 13 days. And we're in third place because right now it's being sorted by miles, and Boo has 81 miles and Chad has 265 miles. So down here we can search by main player name. So if we want to search all the games that contain Chad McBrowsman, we just do that and we hit submit, and it just returns the list of the Chad McBrowsmans. We can also search by highest day. So if we search by highest day, we are actually in first place, which is awesome. And then if you search back by highest mile, then it does this. If there is more than 50 results, then it would paginate, and then you can hit the next button. So now we're going to log out, and we get a message that says we successfully logged out. So if we go back here, we can't log in, but we can log back in, or we have to log in, and then here we go. So now that we're logged in on the main page too, we can select create a new game, or we can continue. So if we hit continue, it brings us to the user page, and here we can see we have lots of different games. If we want to delete a game we don't like as much, we can just hit delete, and then it gives us a message. Are we sure we want to delete? We can say no, or we can say yes. And as you can see, it's been successfully deleted. So everything here seems to be working fine, and then we can play any of these games from the menu, and it remembers our mile count, it remembers our day count, and it remembers which of our players are dead. So that all works pretty well. And yeah, so I guess briefly I'll just go over some of the code. This one. So there were some things I didn't quite get to implementing, but would like to in the future. But yeah, I guess. So start out, basically we have all the basic views. This is the base. This is like the font up here. And then this is the nav bar. So these are the different areas on the nav bar. There's ifs and elses to make sure that we're going to the right places. Trying to get the token to go from the leaderboard to the user page. Since we don't do a PK or a game ID into the leaderboard, I used a session profile PK, which is, I think, somewhat global, and this is able to get that PK as long as it's been set in the view. So this is the one for creating the profile. So if you have an account on the other side of the website for either the mini Facebook or any of the other functionality, if you want to create a profile for it, then all you have to do is come in here and you just add the profile part, so you don't have to use the user form again. This is for the full profile, so if you don't have an account anywhere on the site yet. This is for creating the player, so it's basically just the form as P, so that's in the form section. Here's the delete game. Okay, so this is the big one. This is where most of the stuff happens. So we start by extending the base, then we load the static and the block content. And then here's basically where we load in everything that's saved from the database. So we populate our fields for player 1, player 2, player 3, player 4, player 5. We get the days. Then we load in all the assets for the images. Then we have some styling here. I just put it here so it would be easy to like sort of flip back and forth without having to like scroll all the way down every single time. And then yeah, so here we have the canvases and placing everything on the canvas with its various positionings. This is a dialog box which is hidden by default. It pops up through a function on JavaScript. This almost... It's funny with JavaScript because I think, oops, it still works, but I think that that's supposed to be without the colon. And then, or that's HTML or CSS. I'm sorry. But then, yeah, so here is the stuff for the home buttons. This is all the images. Here we also had to use some JavaScript in order to get the moving background. This is the leaderboard. This is pretty standard, just sort of a table with the usernames and whatever. This is the logged out message, login page, the page for a new game form. Yeah, I'm not totally sure how thorough to be. This is the search. This basically is just, it's an input type, and then when it's submitted, it submits the URL. It does the post, and then we're able to go through with the get query and get the fields and then sort based on them. This is the show profile, so this shows all the games that we currently have active and all the different things that we can do on our page. This is the update game HTML, which as you can see is actually empty. It's because updating game is actually just a post request to a URL, which is then handled on the back, so there's actually no page for it. This is the admin register. Forms, this is create the profile form, and then create the game form. Then creating the player form. And then here we have all the different models. So this has all the different models and methods. I used enums in order to do the injuries and to do gender. Some of this stuff was unfortunately not able to be implemented given the time constraints, but could be implemented in the future, so it's still in here. So there was originally planned to be NPCs, which would have deals. And then obviously the walking and rest for whether we're paused or starting. Then there's seasons. This method here basically just enumerates these and allows you to check them from like a drop-down window. Then this is the profile. This allows you to get scores, get the games, so that we know which games are actually ours. Then the string of the method. The game one is where most of the action takes place. This is where we store all our players. This is our party, miles. All of these have to be int fields in order to post to them. If they're just regular integers, then you can't actually post to them. So, or modify them from a post request. So I actually had to change them to be this. Seasons, the car field. So this also would be able to be modified if that's incremented. Players alive will tell you how many players are currently living. Let's see, the current day. Some of these things are used in the methods themselves and aren't touched by the JavaScript. So these are all the various methods there. Again, all of these methods are actually here. I would just have to figure out where to call them and how to integrate them with the existing code. And then illustrate them with different backgrounds. And probably player messages so you could tell what season it was going to be. And then we have a seasons manager. So the seasons manager ended up getting slightly combined with the game model just because I felt that the code would be easier to call from the game model. It would be easier to store there in order to like interact with it easier. But all of this stuff is still here as well. This is the character method, so this is the one where all the stats are. There's tons of functions in here. The reset function is super important. This is how we reset the character since they're shared across games. If you selected a character from the drop-down menu that was in somebody else's game, it would basically just take the character, and if they were dead, it would put a dead character in your game. So you didn't want that. So we reset it so it would not be dead, have full health and full stomach, and then save it. This is the injuries. I can go over more of this on the JavaScript end as well. This is how we eat. This is how injury happens with our injury chance, and then we roll a random integer, and then we see if we get an injury, and if we do get an injury, then we return, then we do another random roll, and then we decide which injury we have. So this one allows you to get none twice, so you could get an injury, but then still not have an injury, so basically it's like a, oh, just kidding kind of thing. This is the hurt method. So this basically tells us, okay, well, if our health is 0, then we increase our death chance. For this in our death chance, we roll snake eyes, which basically determines whether or not we died. And then as our health gets lower than 0, then we want to do it even more. And then otherwise we just roll it for whatever our current death chance is. So for example, if you have a snake bite, you're going to have a pretty high death chance. So that's getting infected. The snake eyes is the death function. So I mean, it really is the same as, you know, rolling an integer from 1 to 1,000 and hoping that it's 1, but it's more fun if it's 3 of them. At least I thought so. But yeah, so then we set the health. So these are all getters and setters. These can be called from anywhere in the code, which makes it easier to access these fields. This is the die function. And then our last 2 models, we have the NPC one, which, again, this one exists, but it's not currently in the game. I didn't have any sprites for it. Figuring out when to spawn NPCs in, and how to do the UI with the shop, and how to do buying and selling poisons or cures, or taking deals, is something that I definitely could look at in the future, but unfortunately was not possible in the time. And then this is the dialogue here. So this is basically just a model that contains text. And yeah. So then these are the URLs that I used. Log in, log out, create profile with the PK. And then that's for create game, etc. Okay, so the views again, so we have like base views. This is just the base view, and then this is how we save our profile PK in the session. Then this is for creating the full profile, creating the regular profile without the user on the back. So showing the profiles, this one's pretty simple. It's just a detail view. Create game view is the get context data and the form valid. Create player view, and then delete game view and the game detail view, and then update game is the big function that gets called from the JavaScript when we hit the save button, and this is where we load in all the data we want to save from the JavaScript. So it comes in as a JSON form. And so we have to load it in, and then we have to get it from the data. And then we basically populate these fields. And then we have to get the actual game we want to use through the game ID, which is also sent in when we call the game ID function. So that's sent in the URL with the post request. And then we basically save it, and then we save all the players individually. And then this was basically just test code to make sure it actually saved correctly. And then here's where we return the JSON response, either success or false. And then obviously we want to print the exception if there is one. Or if it's just invalid, we return that as well. And then here's the leaderboard view as well. So here's the paginate thing. And then the context object name. And then this is where we're doing the get query set and the context data. Okay, so the last thing I'll try to go over here before I'm done is, well, I mean, here are our various assets. We have the female walk cycle, backgrounds, idols, money, oxen, trees, wagon, food, and wind. And yes, I did hand draw all of these, which is part of the reason why I ran out of time as well. But, I mean, not totally. Like, I mean, I did draw them all, but I didn't, like... Anyway. So here, these are the classes in JavaScript. So basically how this works is we have a sprite class, which basically handles control of the images. So this does animation, and basically we can set all of these from passing them in. And then we draw them in the draw method. This is how we do the animation, which is basically this crops it so that it's not the full sprite sheet. It's just showing a frame at a time. And then, yeah, so this is basically, and then we do the animation of frames. So this basically just moves past the frames. And then this sets the frame rate here with the frames hold. And then during the update method, we actually draw it, and then we animate the frame. So really it's kind of like the draw is actually drawing the frame out, and then the animation frame is moving the animation along, or setting it back to the first one. And so we just call them both the update method, and then we call the update method every frame. So the character extends the sprite class, so it basically inherits all this ability to animate. But then it also has its own properties. So then here are all the properties we saw on the model side. So this information all gets passed from the model fields through to the JavaScript. And then this is the super constructor. And then, yeah, so we set the height, width, color. Here's where we set the health, the current frames, all that information. This was something I was going to do with showing alerts. And then this is where we set all of the stuff to the fields that are passed in. Here's where we populate the various sprites passed in the dictionary with actual JavaScript images, so that they exist as images so we can iterate over them. Like official image objects, you have to do that for every single one of them. Here's the get injured function, so that just gets the property. This is another version of the set injury stats, which basically when we get a new injury, we have to set all of the stats related to that injury so that the code knows how to handle how the player is doing. Then we get if we're dead or not, we get our stomach value, we can set the stomach value. This is how we eat, so basically if our stomach is greater than, maybe it is negative 100. That's strange. Okay. Oh, this is, I think, to prevent it from accidentally going too far into negatives. But yeah, anyway, so then this basically, if we are below negative 100, just don't bother eating, or like subtracting hunger from the stomach. So anyway, so this is how we do it. So if the stomach is less than 50, then we double the hunger. If it's less than 25, we double it again. These are all separate as well, so if it's at 25, it will get doubled for 50 and doubled for 25. Then if it's less than 10, it gets doubled for all the ones above again, and then same. But then as it gets lower than 10, it starts to increase its injure chance. So that line's not doing anything. I think I was gonna maybe do it there too, but then I decided not to. And then when you start to get into below 0, that's when you really start you increase your death chance and your health loss as well. So now you're taking actual damage and you're also increasing your chance of death by a pretty big number as well. So this is how the injure works. Basically, we send a message that tells us that we're injured, and then we reset the current injury, and then when we're done, we set the new injury stats using this method up here. This is the death function that I showed more or less on the model side as well. This is the hurt function. So this basically tells us when to run Snake Eyes as a death function, how many times to run it. Basically increases your chance every time you run it. Obviously I could have done this also in the same way that I was doing the injure chance, which would be like a number greater than your death chance or a number less than your death chance. Basically indicates whether or not you've died. So you would roll from 1 to 1,000, and if your death chance was 20 and your number was less than 20, then that's like a 2% chance that you would die. So I could have done that way as well, which probably would have been more efficient computationally, but this works too. And then this is the async die function. So a function is async when it has to await something. and the way that the text box is working, which is into the utils, is asynchronously. And this is the get infection, so if you break your leg or your arm, you can get an infection. So that's the math for that. And then it also is asynchronous because it tells you that it's been infected. This is getting an injury. So this just returns the string here. If we wanted to put this in somewhere as well, it could be a helper function for that. If you want to say get injury and then print it in the text box, or you want to print it in the console. Then setting an injury, this basically you set the injury to whatever this is, and then you set the stats afterwards. Healing would be implemented if we actually had cures. You'd be treated, and then you set the injury stats based on that. It doesn't immediately set you back to healed. You have to wait another day, and then you'd be set back to healed. But your stats are lowered significantly. And then this would be for resting in the future, and then slow heal if you don't rest. So it's like keep walking even though you have dysentery. This is the update method from before, but with some extra things. And then also if you're dead, you don't animate anymore. And then, yeah, here is the frames for switching sprites. So this basically switches which sprite is passed in. There is no current death sprite, but if there was, this is what it would do. This is for the home backgrounds. This is just the code that animates the background with a parallax. So basically loads them in, creates the images, the canvas. This is where it creates the images here, creates them on a stack, and creates offset, or yes, this is the stacks here, and then pushes them. And then here, basically, we're moving the images and then drawing them where the last one takes off. And then this is how we keep the animation loop infinite. The model functions, these would be functions to use for the various seasons, incrementing the seasons, advancing days, moving. This is where we calculate whether or not people are injured, how fast we go. And then here's some enums as well. This is the main function that has all the information. So here's where we set the bars. This is GSAP. It's an animation add-on from JavaScript, sort of like library thing, where basically we'll animate the bar movement so it's not just jerky. So we have different settings for kid or adult. So we have to get whether or not we're a kid or adult. And if we're an adult, we return this. If we're a kid, we return that. And then we use these properties in the instantiation of the characters. Here we have the getting the actual value. So basically, when you pass information from the model to the JavaScript, it passes it in as a string instead of an actual enum, because obviously they don't share the same language. So there's a lot of these helper functions up here when we're parsing the data to convert the Python data into JavaScript data. So when we pass in true, we return the JavaScript version of true. Same thing here. And same thing here. So this basically takes the enum from Python and converts it to the enum from Java. This is the gender one, again converting a string into these objects that contain all the different either enums, animations, or stats if we needed those. Stats are the same. Here's where we do the object creation. So the ox and the wagon are pretty much stationary. Then the two images for the sides, the two UI elements, those are also stationary, although they listen for a event. It's a resize event here. So when we resize the window, if we go back to the game, if we resize the window, then both the character and the UI elements actually move with the side. So it redraws them depending on where the window is. So you can get this guy to move. I decided not to make the rest of the wagon move just because by the time it gets to like here almost even, like they would all be over here, which would be okay maybe, but then when it gets closer to here, it wouldn't fit. It would just look crowded. Plus I thought it would be funny if the main character could like run away from his family. Yeah, so this is the animation function. So this is where all of the update happens. This is just we restart it every time. If the game's not paused, then, you know, for each layer, we do the parallax. Then we increase the steps. If the steps are divisible by the mile, which is a constant, which is just 5280, then we increment miles. And then this is where we change the inner HTML here. And then if we're not dead, we basically eat, and then we see if we're hurt and we see if we're injured. This was for debugging purposes. And then we get our stomach. If it's less than 50, then we eat from the food supply. We set our stomach back up to full, and then we update the food bar. Same thing with the wagon health. If food is less than 0, then we subtract from the wagon health. Set the food to 100, and then GSAP with the wagon. And then here's where we're updating the day right now. Then this is where we're updating these sprites so that they're moving. Here it's just a for loop so that we can just update all the players at once using a party instead. This is just a small white background to make everything look more visible. This is toggling the pause button, which is connected to the button. This is the save button, so here's where we're setting things out. So we have to get the cookie from the browser. So this is basically just trying to find it from the document. Document and window are kind of how you access the information from the actual browser, as well as canvas, which is the surface that everything's being drawn on. And so here's where we're getting the cookie. Using some built-in Java methods or JavaScript methods. And then here is our post method here. So this is where we're fetching the link with our method. These are the headers that we need. And then here is where the body is basically what we're sending. So we're sending a stringify version of this, a JSON stringify. So this will just basically send a JSON in the body, and then we parse it like I showed before. And then this basically get the response, and then, you know, it tells us if the data is successful or not, and then it catches the error and posts it if there was an error. And this is the utils. This is just basically the show alert function here. And that is pretty much it. I noticed as I was going through it that I actually did not comment everything. So I'm not sure if maybe we'll do that before I end up posting this assignment, just to make sure that everything is explained. But yeah. The end, I guess. Bye. I hope you liked it.